Okay, let's just dive right in. If you're working in a multi-cloud world, the big dream is all about flexibility and power, right? But the reality, well, it can feel like you're trying to conduct this chaotic orchestra of alerts from AWS, Azure, and GCP, and they're all playing a completely different tune at the exact same time. So today, we're going to talk about how to architect a way to turn all of that noise into one clear, actionable signal. And we've got to start with a scene that is, well, it's painfully familiar for anyone who's ever had to carry that pager. It's that middle-of-the-night wake-up call that isn't just one call, nope, it's an entire storm.
You know that feeling, right? That jolt from a deep sleep, your heart's already pounding before you're even fully awake? Yeah, it's the moment every single on-call engineer just dreads.
And it's never just one alert, is it? You grab your phone and you see this, 127 new notifications just lighting up your screen. They are pouring in from CloudWatch, from Azure alerts, from GCP. It's a total flood of raw data that's basically screaming that something is very, very wrong. And this right here, this is the moment of crisis. Your brain is just racing, trying to make sense of the chaos. Are these 7 different problems, or are they all just symptoms of one single catastrophic failure? And which one do you even tackle first? This confusion, this alert fatigue, that is exactly the problem we need to solve.
So, how do we get our sanity back? I mean, sure, better dashboards and monitors can help a little, but the real solution? It lies deeper. It's all about a smarter architecture. So let's build a strategy that moves us from that chaos to real clarity.
The mission here is actually beautifully simple. Take that storm of 127 alerts and intelligently boil it all down to one single, high-context, actionable incident. That's it. That's the endgame.
Now to get there, we need a blueprint. A really well-designed correlation engine isn't magic. It's built on 3 fundamental pillars that all work together to methodically chew through all that noise.
So pillar number 1 is deduplication. Think of this as your first line of defense. It looks at that incoming flood and it just asks, hey, how many of these are just echoes, right? If your web server goes down, you really don't need 30 separate alerts telling you it's unresponsive. This system intelligently groups all of those redundant alerts together, and bam, you've immediately cut down the volume. Okay, next up, we have to find the real culprit. This pillar is all about identifying the root cause signal, finding that patient zero, the first domino that fell in a really complex chain reaction. It's not just about finding what's broken, it's about finding what broke first and caused that whole cascade of failures. And finally, the third pillar, smart escalation. So once the system has deduplicated the noise and it's pinpointed the root cause, it doesn't just blast a notification to the entire team. No way. It creates one precise incident ticket, packed with all the context, and it pages only the person or the team who can actually fix the root problem. This is how you stop waking up the entire company at 3 in the morning. So let's put it all together and just look at the flow. It's a journey. First, we ingest everything, all the raw noise from every single cloud provider. Then we clean it up with deduplication. Next, the system applies its intelligence to correlate events and find that one root cause. And finally, we escalate one clean, actionable signal to exactly the right person. It's simple. Noise in, signal out.
Okay, so theory's great, but let's see how this architecture actually performs under pressure. We're going to walk through a classic multi-cloud cascading failure and see exactly how our system handles it.
All right, just look at this timeline. At 3:01 a.m., our root cause event happens. A primary database over on Google Cloud Platform has a critical failure. Just 1 minute later, an API service that's hosted on Azure, which depends on that database, starts throwing errors. Then, a minute after that, our customer-facing web service running on AWS becomes completely unresponsive because, of course, it can't reach the API. It's a classic chain reaction, spilling across 3 different clouds.
In this slide, this is the payoff. On the left, you see the before state, 127 separate, frantic alerts from 3 different systems. It's just pure chaos. But on the right, you see the result of our architecture, one single incident. It clearly states the root cause was the GCP database failure, it outlines the impact on the API and the web services, and it automatically assigns it to the database SRE team. I mean, it is literally the difference between chaos and control.
So why do we go to all this trouble? Well, because the benefits here go way beyond just a quieter night's sleep for the on-call engineer. This is about achieving real operational excellence.
I absolutely love this quote because it gets right to the heart of the modern monitoring philosophy. Look, we've gotten really good at collecting data.
We can monitor literally everything. But collection isn't the same as understanding. The real goal is instant comprehension of what truly matters.
So what does all this mean in practice? Well, when you find the signal, you fix problems faster, which improves your mean time to resolution, your MTTR. You stop burning out your most valuable asset, your engineers. You finally get a true, unified picture of your entire system, no matter how many clouds it spans. And ultimately, you can shift your team's entire culture from just reactively putting out fires to proactively building more resilient systems.
And that really brings us to the final question, the one you should be asking your own teams. Take a hard look at your alerts, your dashboards, and your on-call process. Is it truly leading you to the root cause faster, or is it just adding to the noise? The answer to that question could be the very first step toward a much, much quieter 3 a.m.